Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Mr. D, this is going to go pretty quick, I think. Mr. D sent me up his Fatboy 8 pill. And, well, it's actually a 2-driving 8. And he sent me his power supply to match it. He proceeded to tell me that what had happened is his radio was on Vox. Which is not a bad thing, but what is a bad thing is when you go and turn a stereo up to 11 in the background and play it for like 2 hours. He said he had something fail, either it be the amp or the power supply. Well, I took a quick look at the amp and I don't see a whole lot burnt. So unless everything quit all uniformly at the same time, like all 12 transistors, I have a feeling the problem's going to be the power supply. So, let me pop the tin on this thing. We'll take a hot look at it, and then we'll pop the tin on the power supply and we'll see what's going on with it. Let's take a little fly around the universe here. I don't see any pop 10 ohm resistors anywhere. I don't even see any heat discolorization on this little girl. So I have the feeling that our problem might be over here. But have faith, I'm going to test this. But I'm going to start out over here. Okay. So what we got going on is this voltmeter, it's hooked up to the back of the power supply. Yeah, you can see that. And we got the power supply hooked up to the variac. So the variac's humming. Seeing very little output power from this, from here. Brother, I think we found your problem. It's here. And that thing's got enough transformers in it to run like a 16 pill, bro. Whew. Okay. Well, I have seen this problem before. We've got one burnt wire, but that's from them doing the solder work on the, or the heat shrink work on the wires. One of your bridge rectifiers is gone. I don't stock those anymore. I don't know anybody who uses those anymore. I'm not going to order any. What I am going to hook you up with is this. One rectifier to do the job of them all. I'll pull all this garbage out of here, all these little tiny rectifiers. I should have two. I'd rather put 2 of them in there. I do, right here. Here's the other one straight from the China boat. These things work. They're heatsink mountable, and this is 200 amps. It's a 200 amp submerged diode rectifier bank. So I can take it, I can plop one down on this heatsink and plop the other one down on the other heatsink, and we're off to the races and running. Just got to change our eyelets. So I think this turns into a power supply rebuild, and you're going to get a higher duty cycle out of these than you will the little 50 amp bridges. Man, I built with those for a long time, and they just kept failing. I'd send them out there in the world, and the power supplies would come back, and the freaking base boxes were coming back left and right that had those little bridges in them. I just lost all faith. I was mounting them on huge heat sinks, and so what I did is I ended up taking one of those 50 amp bridgers and I submerged, or went and ground the bottom off on a sander. Come to find out they got these little tiny little 6 amp diodes in them, and because they're submerged in epoxy, it allows them to have more of a contact surface area, so it allows them to dissipate more heat other than just an actual air cooled diode. So first things first, what we're going to do is we're going to pop all the transformer output leads, all the yellow wires, all the yellow wires over here. We're going to take all them off the bridges. And what that's going to allow us to do is isolate the bridge network from the capacitor bank and from the transformers. And we're going to do the variac test again, and we're going to see if we get any resistance in the variac as we start to load it. Because if you see here, we're starting to get a little bit of voltage, but that's with 45 volts going in. We should have probably 5 to 9 volts coming out of this thing. It's an unregulated supply, so we're going to see it drift up. The other thing is that there's no protection in here. There's no bleeder resistors of any kind. So, I mean, when you turn this thing off, even without the amplifier being in line, it should bleed the voltage off the caps, even though that these are only 12 volt caps. And for a long time I didn't think that that was a safety issue. For the electronics safe, it's an issue. For the electronics sake, it's a safety issue. So we'll put some couple mega ohm resistors in there, and we'll get that to bleed down for us automatically once you shut the power supply off. But yeah, let's start breaking it out and see what. Okay, so we've isolated out all the transformers. We got our breaker on. No humming, no arcing, no sparking. Beautiful. So that tells us that the most expensive bit of this whole power supply is salvageable, which is the transformers. So the next thing that we're going to do is we're going to break all this stuff out, and we're going to change how all the back end of this power supply is wired so we can make it run with this heebie-majiggy, which is really simple. You take the AC off the transformer, and the other pole of AC off the transformer. You take one, you tie it to ground, take the other one, tie it to hot. But instead of having to run multiple little leads, we just can run one wire. One wire. So we're going to change all that around. That is going to take some time. So, on that note, this will be a hot minute. I'll be back. Okay. Let's take a look here. As we can clearly see, the epoxy's cracked out on this tab. The epoxy down the middle of this bridge is snapped in half and broken. Now I left this one on there because I wanted you all to look at it. I think that might have gotten a little hot. And the epoxy down the middle of this one is also cracked. Now there's a little bit of a significant hole here because there used to be a friggin' tab that was attached to that, but that's all burned up and blown out. Yeah, we're going to pan. We're going to tilt. We're going to come over here. This bridge is completely cracked in half. This bridge is cracked in half. This one has a burn scorch mark that goes across from AC to AC, and then this one is melted on that tab. That's that. So now, what we get to do is we're going to strip this down even more than we already have. We're going to mount up our new replacement bridge. And I think what we're going to have to do is we're going to have to mount this hole. We're going to have to change where this hole mounts up just to a different spot back here. So it means we'll have to re-drill in the cabinet where this is mounted. Yeah, look at that spaghetti mess. Isn't that hot? Have faith. It's going to look like new when I'm done. It's 3:30 in the morning. It took about 3.5 hours. But it's all wired up right now. Not digging that one fan. I think the bushing's going out on that one fan. If that's the case, it's going to get changed because everything else in this damn thing did. It's got new rectifiers. All the power wires have been rerouted. Everything's zip tied, organized, nice and neat. Heat sink is remounted. It's got copper distributions in it instead of little pieces of 22 gauge Teflon. And screw this shit, I'm going to bed. Good night. Okay. Alright, so let's see. It's 9 o'clock in the morning. I got 4.5 hours, 5 hours of sleep. So power supply's off the bench now that we know that's working. I want to go back and put it on the oscilloscope, make sure we have no leakage, and a couple of the little small tests, but we'll do that here and later. I wanted to run over here and I wanted to check out your 2x8 first. So it's two 2290s drive-in, 8 matched red dot Toshibas. Now, the way this works is you got your preamp, and you're going to have high, which is going to be just your 8 pills, and then you got low, which is your driver. Okay, so then that's just your 2 pill section. So let's go ahead and flip these up. Oh, no, wait a minute. The other thing I'm going to change is the way the fans were wired inside of this. The way they were set up is as long as the power supply was on, the fans were on. So before I change it, I'm going to call you and double check that you didn't have them wire that for a reason. Like I could see that the guy would want to have the fans running if the power supply was on. Just that. Something tells me that you had them wired like that for a reason. So I can see where they would have hooked it up over here on a remote jack, but somebody had soldered it down here on the distribution bus. Let me double check with you on that before I go and get carried away, but we're just going to test this thing real quick. Hello. And what we got here is a 1,000 watt slug in PEP, 1,000 watt slug in average, 5 watt slug in reverse back from the bird, 10,000 watt dummy load, and of course the 5 watt slug set between the 955 and of course the 2x8. So we have this in the 2x position, so full deflection is 2,000 watts. Hello, audio. Let me flip this down. So full deflection is now 1,000 watts. Hello. Here's our whole 15, 20 watts of drive. Click that back up to 2x. So we'll try this on low. Hello. Hello. About 400 watts is what we're getting on low. We'll bring on the 8 pill section. Hello. Hello. So we're getting about 900 watts out of it. Just the 8 pill section itself. Make sure our variable is all the way open. We're going to bring our 2 pill driver online. Hello, audio. RF getting in the mic there. Hello. So we're seeing about 1700, and this is on 14.4 volts. Hello. And about 400 bird. Let's take a quick look at the input tune. Hello. Oh, wrong 5 watt slug. Hello. About 1 watt worth of input reflag. Which is not T-bag. Not T-bag at all. So let's make sure our sideband delay is working. Sideband delay is working. And of course, this is Fatboy's bias circuit that's right here. And then this is, let's see here. This is the low high, part of the second and low high, and then your bias. So this is your delay. And everything's working great inside of here. It's a tiny bit out of tune. We're going to do some power wire upgrades to the inside of this thing. And then I'm going to go ahead and put the 5 waters in there per your request. The resistors, that is. And we're going to polish it just a little bit. And then I'm going to check the power supply, put the tin back on this thing, then marry this thing up with the power supply and give it a test run. So give me just a hot minute. We'll be back. Okay. So I went in and touched a few things. We did a power wire upgrade to it, and that's pretty much about it. Just want to do a before and after with the power wire upgrade. As you can see, we're barely squeaking. I mean, we were like 1,500 watts before, right? Oh, so we picked up about 200 watts. Oh, See, what would that be? About 1,000, 14, no, 1,000, 12, 14. This is about 1,500 watts before. Now we're doing a solid 16. Oh, oh. We picked up a little bit of bird. And give me just a second. I'm going to tune this just a little, just a smidge, and we're going to see what it does. Give me just a sec. Okay, so we made some small changes in here. Just small ones. Let's see how we did. There's another 200 in peak. About another 100 and so in bird. No problems. Okay, so this thing's right. It's all put back together and it's ready to go. So let me put the lid on it. Shoot, let me call you real quick and make sure that we got the fans wired the way you want them. And then we'll slap the lid on it. I can't wait to see how this thing's going to run on its power supply, since it's at non-regulated voltage. And it'll probably, now with them bigger diodes in there, it'll probably come up in its output power quite a bit. So I know the voltage is going to come up, because right now we're feeding this thing with like 14.5, so that means the box internally is running at about 13.8. So this thing's running real strong now. But we found 400 watts inside your box, or 300 watts inside your box. It wasn't there before. So yeah. Let me get onto the phone. I'll be right back. Okay. Back in the saddle again. So we're going to hit this with the 955. We're running off this power supply now. 2x8's up and running. We even cleaned the little bit of schmoo that was on the lid off. Got you all polished up and ready to go. Let's hit this thing and quit it. Full 2,000. Way better than the 1.5 watts that we had when we started. That's it, man. You're all back and running. And I'm here to tell you, do the world a favor. Don't leave the Vox on and play the radio no more. It'll help you out a ton. Oh, brother. Not the first time I heard that. The other good one that always comes around is the cup holder problem. The guy takes his mic, throws it in the cup holder of his truck, hops out, comes back 20 minutes later, and shit's burnt to the ground. Alright. Let's do one last thing here. Let everybody know I've been in here. You notice I don't sell these stickers anymore, right? Because I had a guy that bought a bunch of these from me. He bought like 5. And then he took all his burned up garbage, he slapped the stickers on them, and then he put them on eBay for sale. And so the people called me up and they're like, so, did you work on this box? I was like, nope, I did not. Well, it's got your sticker on it. And I said, well, yeah, you can buy the stickers on a web page. So now the only way to get the stickers is if the amp's actually been here. And remember, if that sticker's on any amp that you see ever on eBay, ask the seller for the video. Because not one thing leaves here and doesn't have a video made for it. Most of them are put into private and they're not on public production like this one is. But they're out there. So if you are looking at buying one of my boxes, and just because the sticker's on it, ask the seller for the video. That's it, you guys. We're done. This little project is done and over with. Brother, I'm glad you didn't pop any of the very precious Toshibas that are in this thing. I'm glad that it was a simple, cheap fix over here. Only a couple $100 to repair this. So, I'm off to the races and down the road. Gentlemen, my name is BBI. Without a shadow of a doubt, I'm the biggest mud duck in Idaho. Come check us out, www.bbiamps.com. Come find me, well, on Facebook, Twitter, Snapchat, Instagram, and as always, if this is your first time watching, and you like this little dog and pony show that you got to see, make sure to click subscribe and hit the notification button. That way you can follow along with the rest of us and all these crazy little retarded antics that I do over here. Guys, I'll see you. And believe me when I say this from the bottom of my heart, I appreciate every single one of you and all the projects that you guys have been sending me now for years, because I don't get to be here without all of you. Bump, bump. BBI gone.